Hardy. He is a professor at Arizona State University. Now, he started out being interested in planning and decision-making capabilities for autonomous agents, and he's still working on planning and decision-making, but now he's more interested in human-aware AI systems. And an interesting tidbit about him is that he's also very interested in ethical issues in AI. He's, for example, one of the founders of the Conference on AI Ethics and Society, EIES, as well as the Partnership on AI. Rao, go for it.
Thank you. You can hear me, right?
Yes.
Yeah, okay, great. So I'm going to be talking about explainable plans and decisions. Like everybody else, I took my 1.5 hour talk, added a few more slides, and I'm going to complete it in 15 minutes, so it should be fine. So I should start with this, I believe. I believe that AI and OR are two great areas separated only by a common set of problems and foundations. I do research on planning and decision making. I have used OR techniques, what you would call OR techniques, what you call AI techniques. They're all basically very connected. I've written papers on IP encodings, linear programming encodings. I also believe, very much like the OR folks, I hope that in modeling problems, especially in the many human-made domains with explicit knowledge. I'm actually not particularly interested in the kind of let's just learn everything from scratch as if evolution is just starting right now kind of a thing, and under the guise of what they will call generalized approaches. I would like to actually see interpretable AI systems with planning capabilities in some time little earlier than the end of time and end of rapture. So I really am very much happy to actually model domains and then learn on top of them. One thing I do think is different with respect to where I come from in the AI conferences and the OR conferences and the OR community, which is actually useful in understanding some of the other stuff, is I sort of with tongue in cheek, I tell my students that they're really solving the same problems, AI and OR, except the difference is OR says, here is our trained student who can model your problem and solve it using our solvers. So you actually send your students or your trained people along with the solvers approximately, whereas AI says, here's your system, it just does it all Nike-like, and let's just hope that it all be fine. So keep that in mind. So now I'm supposed to be actually talking about explainable AI, and who are we giving explanations to? Humans. And let's first get something straight. Both AI and OR have done extremely good job of ignoring humans for quite a lot of time. They do it in slightly different ways. I mean, come on, who are we kidding? I mean, we got into STEM just so that we don't have to deal with humans. So, the AI way is if you stay far enough away from them, for example, on Mars, like that Mars rover, are basically mostly fight with them, like in all these games, competitive games, zero-sum games, you'll be fine. And if it's not fine, then just drag them into the land of AI. So in fact, what used to pass for human AI interaction is humans giving up their lives and going into the search queues and data structures of the AI systems to figure out what is going on. This is, for example, what used to happen in mixed initiative planning. The OR way, and I'm an outsider to some extent, but based on what I understand, is we'll send one of our guys, the so-called horse whisperer, along with our methods, and this guy will do the human interaction. So we kind of train this guy to actually talk to humans. We are barely human ourselves, but we'll make them, when I say all STEM people are barely human. And so we train our guys to learn to deal with humans. And here's, for example, a nice paper that I looked at, which is Communicating Analytic Results, a tutorial for decision consultants. This decision consultant is not a program. It is a human being, and you're training them to how to translate what your OR techniques are doing to the normal people. And it's a very useful thing to be able to do. And this is how we have managed to ignore humans. I don't know what's going on in OR, but in AI, there has been some issues with respect to ignoring humans. Suddenly, humans have become quite the sought after window dressing in AI. So we have like very, very many different kinds of AI, human-like AI, human-centered AI, human-compatible AI, human-in-the-loop AI, and human-aware AI. And that's the last one that I'm going to talk about. There are beautiful, very good Devil's Dictionary style definitions of the rest of the AIs, but human-aware AIs and explainable AI is what I'm going to be talking about. So my own background in human-aware AI, essentially we are focused on explainable human-AI interaction. Our setting involves collaborative problem solving, where AI agents provide decision support to the human users in the context of explicit knowledge sequential decision-making tasks. I will talk about how I extend it to tacit knowledge tasks, but we mostly do explicit knowledge sequential decision-making tasks, such as mission planning. And in contrast, of course, much of the work in social robotics in HR, I will talk about later, has focused on tacit knowledge tasks. And we sort of assume that the AI agent has either prior access or learns the human model. So we both do the learning as well as think a lot about the inference part. We develop frameworks for proactive explanations based on model reconciliation, getting my mental model to reconcile with your mental model of my capabilities. That's basically what explanation is from our perspective. And we demonstrated the effectiveness of what we do in our techniques in actual systematic IRB approved human subject studies. Anytime somebody says, I like humans, ask them if they know what IRB is. If they don't really like humans. They think they do. So you actually have to get these things, and we have done that sort of studies. There's a bunch of things that, including, some of our old work, the work that we have done up until now, it's coming out as a monograph, at the end of fall. And also there's a human-aware planning and scheduling track in ICAPS, and then there's human-aware AI tracks in AAA and also in ICHKAI. Some of them have been sort of catalyzed by my pushing it. Okay, so the three-part agenda for today is essentially the following three things, and I'll see how much I can get through. And of course, if not, I can always quickly get through the slides, and then I'll send you the slides later on. So the overview of explanations as used in human-human communication, and considering how the different tribes of explainable AI differ in using this. Everybody talks about explainable AI, but they're talking about completely different things. I want you to at least understand. I mean, some of you do understand, but it's worthwhile acknowledging the elephant in the room. Then I want to talk about overview of our own work up until very recently on explaining model-based planning by reconciling mental models. And this is the stuff that we have done a whole bunch of work on, tons of papers, good students, all that fun stuff. And then we have given tutorials and all that stuff. And then I will end, hopefully, with ongoing work on sort of thinking of, even if your AI system doesn't actually use internal symbolic models, even if it uses so-called inscrutable models, this whole issue of neurosymbolic systems has become a big deal in AI. And it's not, I think the most important reason for neurosymbolic systems is not that the systems must have definitely internal symbolic reasoning, but that they should talk to us in means that we understand. The whole point of AI should be that they come into our world, not we going into the robots world and the AI systems world. And so for that, we need to have symbolic lingua franca. And so I talk about some of the work we are doing, as well as some little work that's been done before by other people too, on actually making local symbolic models to explain your reasoning to the humans, the AI systems reasoning to the humans. I actually just put up, we put up a position paper on arXiv just a week back. You might be interested in looking at that. So that's the three-part agenda. Let me quickly get through some of these parts. So explainable AI has very different tribes. There is explainable classification, which is what people say when they say explainable AI in ML or explainable ML. So you have basically a tacit, a machine learns inscrutable features, and typically the explanations are sort of showing saliency explanations, showing an annotated region saying these pixels are the ones that seem to have made some difference in me coming to this particular classification. In some cases, there might be human given features in machine learned systems. I think Cynthia, for example, talks about it. And those cases, basically explanations in terms of feature weights and attributions, and in terms of also coming up with interpretable models. There's explainable behavior. Classification is one shot. Behavior is actually a sequential decision making, and then actually showing a behavior in front of an observer or a collaborator. There too, you can have tacit interactions, wordless interactions, or you can have explicit knowledge interactions, potentially with some shared vocabulary, but potentially different models. So explainable, the tacit interactions typically is what winds up being looked at in human-robot interaction. Explicit interactions wind up going in human-robot interaction as well as planning and maybe even OR. Explainable behavior, the planning decision-making thing that I do, is typically explicit knowledge tasks, with the caveat that we are also talking about, we don't really care how the system works, as long as it can be advised by us in symbolic means and it provides explanations to us back in symbolic means. The two things that were on the right-hand side are some of the kinds of case studies that I look at, human-robot interaction, the one on the top with, there's a commander in a remote location and the robot is going through trying to do some simulated search and rescue scenario. And the one in the bottom is a sort of a planning decision-making tool, mission planning tool, providing support to a human mission planner, and except that in this particular case, the suggestions made have to be explainable. And if the humans ask why this suggestion, you should be able to change the plan appropriately so that it will correspond to the implicit preferences that are expressed by this why question. So those are the kinds of things that we do. But why do systems even have to give explanations? This is something that we also should ask. And a certain bigwig in Facebook basically keeps saying that Facebook makes millions of recommendations per day and no one ever asks for explanation. So why the heck do you need explanations for any AI system decisions? People don't need them. Well, it turns out that for important decisions, people do wind up requiring explanations. And furthermore, even when Facebook winds up doing suggestions to you, if it doesn't give an explanation as to why it is making that suggestion, you have no idea what it has understood. More recently, some of you may have realized that, may have heard that Facebook saw like a video, a photograph of an African-American are actually a black man, I think in UK, in some situation, and then asked the user, do you want to see videos about primates? This might be very egregious and it might hurt your sensibilities, but realize that if it didn't say that, and if it just started showing you subtly lots and lots of primate videos coupled with other videos, it has misunderstood. And you don't know that it misunderstood. So explanations are actually the way we understand the failure modes of systems. And so we should care about that. In terms of explanations in the systems, both in AI and OR, explanations have been used to control search within the system itself. Those are the kinds of things that we have looked at before humans became important. Now, explanations also take into account providing explanation to other systems or other humans in the loop. And this is the humans in the loop part that I'm really interested in. And it turns out that people confuse these different kinds of explanations as if they are just explanations to the human. For example, if you provide a 2 gigabit certificate of optimality of your plan, that's not an explanation to the human unless the human happens to be an AI system themselves. Okay, you have to think in terms of the kinds of explanations that would make sense to humans. The use cases for human in the loop explanations include debugger trying to, like human as a debugger trying to flag and correct the human system's behavior, human as an observer, a lay observer or an expert observer. Many a time human, AI systems basically assume that we are giving it to end users who may not be experts in either the way the system works or particularly in the domain. And so you have to take that into account. As a collaborator, as a student, so the machine is in a teaching role, or as a teacher, which means you are teaching the machine your advice, your preferences. In fact, one of the biggest problems in all these quote unquote biases and so on in LLMs or any other systems is that there is no simple way in which you can advise them to not show certain kinds of behavior. It's not that we don't think bad thoughts. We have a system too, which kind of censors them. And so we know what to say and what not to say. LLM just says what comes to its mind. And then the tasks themselves can be one shot versus sequential decision. I'm a lot more interested in sequential decision tasks. And then finally, the interaction can be one epoch versus longitudinal. One epoch means you just interacted with the machine once. Longitudinal means you're interacting with the AI system for multiple iterations. In that case, things like trust become important. And in fact, in the beginning, you might need explanations, but as you get used to the system, you might not ask for explanations.
You have about a minute left.
What?
You have about a minute left, just to give you a pointer.
Oh, okay. I'm sorry. So when and why humans ask for explanations from each other, when they're confused, surprised by their behavior, when they want to teach the other person, when they need explanation, and then the explanations have to be sort of made, customized to the humans in the loop, and the mental models. And how do humans exchange explanations? Sometimes they do pointing, but most of the time we do symbolic or explicit knowledge explanations combined with the tacit, annotation explanations, and that has to be taken into consideration. So coming back to my three-part part, and then maybe I'll just spend 1 minute talking about my model thing. The work that we do essentially assumes that you need to consider not only the model that the machine has of the task, the robot's model, but also the human's model of the task. And then finally, humans' model of the robot's capabilities. And explanations are really about this MRH. And the whole point of explainable reasoning for us is making sense, for the machine to make sense of its decisions in the context of MRH, which is the human this thing. So longitudinal interaction for us winds up being start with an initial estimate of MRH, which is what the human thinks of your model, the AI systems model. And then you can do model following, which is conform to what the human expects. So just show explicable reasoning and also show predictable reasoning. Or model communication, in which case you're actually providing explanations, and the explanations wind up being deltas between your model and the human's model of your capability. So a difference between MR and MRH. And I just want to probably end with, given that Sven is looking at me angrily, I want to end with this idea that the way the computation of the explanations is done is essentially as a search in the space of models. This search, in the most basic case, it's a search in the space of models. And you can compute explanations this way, and they will have all sorts of interesting properties in terms of minimal explanations versus monotonically complete explanations. And we can extend this also to support either proactive explanations or just explanations only with respect to a file. That means somebody asks, why did you not do this? And you then provide an answer as to why their way of solving the problem is not as good as the one that you wound up showing. And then the last thing I just want to show is in our ongoing work on symbolic lingua franca, we're basically looking at, irrespective of whether the machine has internal symbolic model or not, with respect to a file-based question, it needs to provide a symbolic explanation. For that, it means it needs to have a symbolic vocabulary that it shares with the human. It needs to learn the denotation of that. It could be demand-driven. It could have been amortized over a period of time. But then you are then transferring your whatever saliency region or whatever explanations from your internal representation into this symbolic vocabulary. So that's one thing that we do. I'll go over all of this. There's a paper there, and then I'll just start with the summary. There are multiple XAI tribes with very differing interpretations of explainable AI. Explanations can be thought of in terms of mental models. The three-model framework provides a pretty unifying view. There are missing the slides that I skipped over, which sort of connect the three-model view to what is required from explanations in the human-human communication, and whatever other motivations neuro-symbolic AI might have. One thing for certain is that explanations are best exchanged in symbolic form, which basically means you might want to learn a symbolic vocabulary. You, the AI system, might want to learn a symbolic vocabulary to live in the world that humans made, rather than expect the humans to learn to figure out what's happening in the 15th layer of a 150-layer network to make sense of what the reasoning is. So this should be part and parcel of the the promise of AI from my perspective. So I will stop here.
Well, thank you. I mean, I think it was a fantastic overview of explainable AI for human-aware decision-making and some of the issues that arise. Obviously, you could have talked for hours, but I think you made the most of your time. It's a lot of information that you conveyed.